YouTube channel. My name is Pratibha SR. I am studying BE in Electronics and Communication Department at Sri Venkateshwara College of Engineering. Today in this session, I am going to discuss about dependence of Fermi factor on temperature. Before going to the topic, I would like everyone to subscribe my channel.
Let us go through the content. First, let us know what is the meaning of Fermi energy, meaning of Fermi factor, and let us discuss about dependence of Fermi factor on temperature. First, Fermi energy. Let us know the definition of Fermi energy. The energy of electrons corresponding to the highest occupied energy level at absolute 0 Kelvin is called as Fermi energy, and the energy level is called as Fermi factor. Fermi factor is the probability of occupation of energy state by the electrons in a material at thermal equilibrium. Now let us discuss the dependence of Fermi factor on temperature and energy. When the temperature is greater than 0 Kelvin, the distribution of electrons over a range of allowed energy levels at thermal equilibrium is given by Fermi-Dirac distribution function, and the equation is written as f of E equals to 1 upon 1 plus e power E minus Ef by kT, where f of E is the probability of occupation for energy level E. Ef is Fermi energy, where T is the temperature in 0 Kelvin, and K is called as Boltzmann constant, which is equals to 1.38 into 10 to the power minus 23 joule per Kelvin. Now the temperature of Fermi factor on temperature and energy is shown as in the figure. Let us verify this Fermi-Dirac distribution function, whether it is as per the definition or not. So as we mentioned above in the previous equation, that f of E equals to 1 by 1 plus e power E minus Ef by kT at for the given conditions, temperature equals to 0 Kelvin and E is greater than Ef. That means let us consider all the energy levels below the Fermi energy level, and let us try to calculate the probability of occupancy for those levels. So that what we are going to do now is trying to calculate the probability occupancy for all the energy levels below the Fermi energy level, where the temperature is equals to 0 Kelvin and E is greater than Ef. At temperature is equals to 0 Kelvin and E is greater, when temperature equals to 0 Kelvin and E is greater than Ef, then the equation E power E minus Ef by kT, which is equals to e to the power minus infinity, which is equals to e to the power minus infinity. Then we have to substitute that value e to the power 1 by infinity in the given equation, which is called as f of E equals to 1 by 1 plus e power E minus Ef by kT. Then we obtain the equation as 1 by 0 plus 1, which is equals to 1. Therefore, the probability of occupation can be written as 1 by 1, which is equals to 1. This indicates that all the energy levels below the Fermi energy are completely filled at absolute 0 Kelvin temperature. Now let us see the now let us check the probability of occupancy for all the energy levels above Fermi energy levels for the condition where temperature equals to 0 Kelvin and E is greater than Ef. Now we can write e power E minus Ef by kT equals to e to the power plus infinity, and where e to the power infinity, which is equals to infinity. So if we put infinity for e power E minus Ef by kT in this Fermi Dirac distribution of the probability of occupancy for a given energy level E, and it can be calculated as 1 by 1 plus infinity plus 1, which is equals to 1 by infinity, which is equals to 0. Next, this indicates that energy levels above Ef, are completely empty at absolute 0 Kelvin temperature. Now let us try to calculate the probability occupation of temperature which is greater than 0 Kelvin for E equals to EF. Now we can put the value for E power E minus EF by KT, which is equals to E naught, where E naught is equals to 1. Therefore F of E equals to 1 by 1 plus 2, which is equals to 1 by 2. So whatever may be the temperature which is greater than 0 Kelvin for E equals to EF, the probability of occupancy will be half. Now let us try to calculate the probability of occupancy of all energy levels at the temperature is given as exactly equal to 0 Kelvin for E equals to EF. Then we can substitute the value for E to the power of E minus EF by KT will be E to the power 0 by 0, which is not defined. Therefore, we cannot calculate the probability of occupancy of Fermi level at 0 Kelvin. So at probability of occupancy of Fermi level when temperature is equal to 0 Kelvin will not have a definite value. So this is the significance of Fermi energy. Now at 0 Kelvin, due 0 Kelvin temperature, and we can't define the probability of occupancy level. But for temperature greater than